Alright, so here we have problem 2, and there's actually two smaller problems within this problem. So let's first look at question A. Use the less than sign to order the following fractions. And you see a jumble of random numerators and denominators. And it's 10 to 17ths, 12 19ths, 15 23rds, 20 33rds, 60 over 91. First, if we write these all out. So 10 over 17, 12 over 19, 15 over 23, 20 over 33, and 60 over 91. When we're comparing fractions, we need either a common numerator or a common denominator. In this case, which do you think it would be easier to turn them into have a common denominator or a common numerator? I think the best choice over here would be to do a common numerator, because as you can see, 10, 12, 15, 20, and 60 are all very closely related. Their smallest common factor, their least common multiple is 60. So we don't have to change 60 over 91, but we do have to change the rest of these numbers to have a numerator of 60. So for example, 10 17ths, and if the new fraction, its equivalent fraction, has a numerator of 60, meaning we multiply 10 by 6, we also have to multiply the bottom 17 by 6 as well. And that gives us 102. Now let's do 12. And it still has a numerator of 60, but remember, now we're not multiplying by 6, because how many times did we times to 12 in order to get 60? We got 5, right? 12 times 5 equals 60. So what's 19 times 5? That would be 95. Okay, so we keep doing this for the rest of the fraction as well. 15 times 4 equals 60. So what is 4 times 23? That would be 92. 20 times 3 equals 60. What is 33 times 3? That would be 60 over 99. So now that we have all of these fractions with a numerator of 60, it's much easier to compare them. I want to tell you something. When we compare this, we have to, like for the actual answer that we submit, we have to use the fractions given. We cannot use these equivalent fractions. So first, I like to just order these, right? So what is the least over here? If all of these numbers have the same numerator, we're trying to find the one with the greatest denominator, because it's being split into more parts so that each part is smaller, right? So the biggest one over here is 102, meaning that 10 over 17 is the smallest. Okay, and I just like to have that crossed out after I did do it. Now we have, what is the second largest denominator over here? That would be 99. So 20 over 33 is next. Cross that out. Now we have 95. 12 over 19. Crossing that out, and we get 15 over 23. And the one with the smallest denominator is 60 over 91, meaning it is the greatest. So our final answer for problem A, or for question A, would be this right over here. Let me shrink it. Okay. So, scooch this over. I want to keep my work. Okay, I'll put it to the corner right here. Problem B. Out of the following fractions, and you see huge numbers, which one is the smallest? So, as you can see, this is really just 1,900. It's just 1998, 1998. Seems like a year. And over here it's 1999, 1999. Next, we have 1999, 1999 over 2,000,2000. Finally, we have, okay, so this last fraction right here it would be the following. 2000, as you guessed, and it's probably over 2001. There was a typo when we made this problem. Okay, so this is an interesting problem. So pause the video and see which one you think might be the smallest, least. All right, I'm thinking that you chose this fraction, didn't you? Because if you look at it, its numerator is the least, and so is this as well. So you are correct. This is the smallest if you chose that. But why? Can you tell me why? Well, you don't just look at so you first start with looking at the numerator and denominator. As you can see, if you imagine a rectangle or a super long one, and it's cut into 1999 parts, right? Each of those parts has to be greater than if it was split into 2000 parts or 2001 parts. So we're talking about that this under 1, this piece right here is the greatest piece, is greater than either 2000 under 1 or 2001 under 1. So I'm just saying that this one has the biggest pieces. So if it has the biggest pieces, then how come it's the least? Well, now you take those pieces and you eat 1998 of them. Right, so that's also a large amount, but the pieces are greater, and you still have a amount left, right? Now let's compare this to the second fraction. If we were to split the same amount, the chocolate bar, into 2000 parts, each part would be smaller, meaning you could say in a way that each of the pieces are more precise. And if you take this more precise parts and you color in more of them, or you eat more of them, you eat a more precise number than the first fraction. And so is the second fraction. It's split into smaller parts, yes, but you do have a large number of them. And also each of the pieces are more precise, meaning that these are each closer to a whole chocolate bar than this one. So which one is the smallest? That would be the first fraction.